Okay guys, so I actually ended up bringing the heads over to this shop because there was just too much chaos going on over there. But so far on the cylinder heads, what we did is we vac cleaned them, we disassembled them, I magnafluxed them, and then I checked out the valve springs. The valve springs were junk. The valves, now I was really surprised at how much wear the valves didn't have. I mic'd the valve stems, and one of the things you want to look for on the valve is you want to mic this valve stem. And so I mic'd the valve stems, and the valves have no wear whatsoever on them. They're like brand new valves. So I was a little bit perplexed by that, because usually you see, especially on the 3/8 stems on the earlier big blocks and even the small blocks, the valves guides have a tendency to wear. So I called the customer and I thought, yeah, these valves, are in really good shape. I'm surprised. And the other thing is the valve springs actually had spring shims under them. So that tells me that these heads have been reworked or rebuilt before. And he was thinking, no, it's all original. So he called his dad, and it turns out that at one point back in the 70s, I believe, his father said, oh yeah, we had the heads redone at a machine shop and they put all new parts in them. So, and it wasn't, the thing didn't have any very many miles on it since then. The parts are like new. So he wants to go ahead and reuse the valves. We did clean them up and regrind the surfaces and measure the margins, and everything looks good on these valves. So we got a good set of valves, with the exception of 2 of the intakes. We put it on the grinder and it didn't clean up all the way around. It only touched part of the valve here. So this one is warped a little bit, and we would have had to end up grinding way too much off of it and make the margin too thin, because the thickness of this margin is important. That is what allows the valve to transfer heat. So if this gets too thin when we cut it, it's no good. So that valve is bad. And then the other valve, I don't know how well you can see this, but it had gotten water in it or something, and we got a lot of pitting on the stem right here. The valve measured good and everything, but we had so much pitting. Whenever you have pitting on a valve stem or anywhere in here, you don't want to use that valve. You want to chuck that out. You don't want to. We don't take any chances with valves. Anytime you have valve wear, any kind of valve wear or damage on a valve, you chuck them. Alright, so let's take a look at these heads. What we got going on the heads here is, of course, they've been cleaned up. Now, we did check the cylinder heads for warpage, and what we found backs up the customer's theory that this thing got hot. These heads actually have quite a bit of warpage. Considering the fact that it was still running, we got about 7 or 8 thousandths warpage here. So they always bow up in the middle, and of course it's upside down now, so it's low. We had a low spot here on both of them, so we're definitely going to have to resurface the heads. The other issue is the valve guides. They did replace the valves, and the valves are in really good condition, but when we look at the valve guides here, the valve guides are pretty sloppy. So we're going to have to put valve guides in these heads. We did have the conversation about putting hardened seats in, but I gave him the option because I looked up the casting, and these castings have an induction hardened seat here from the factory, so they were actually compatible with unleaded fuel. Now, as far as these castings go, this is our 346. Now, I got online and I thought, I know that, and my impression was, oh, these are smog heads, because now, and by the way, I did make a mistake in an earlier video, a couple of them actually. One of them is, I told you that these heads this car is a 74. It is not a 74, it is a 72. He corrected me. So it's a 72. These heads were pretty standard on pretty much every 440 after that, and they even used them on 383s. So I did some research, and you know how you get on the forums online and stuff? And of course on the forums, everybody has, their own opinion. It turns out, a lot of people said, oh, those are nothing but boat anchors, it's scrap iron, they're garbage, you need some of the earlier heads. What I discovered by doing a little bit of research is that Richard Petty actually used this casting in some of his Grand National cars where he basically went out and destroyed the whole field out there. And that was back in the days when they actually used factory stock parts in those cars. Those days are long gone, but in the early 70s they were doing that. And he actually had a set of this, he was using these castings for his championship winning race engines in NASCAR, which really surprised me. But now obviously they were highly worked. They were fully ported. They had bigger valves in them. I mean, they tricked them out to the max. But this casting has kind of been considered a smog casting. But once you actually look into it and research it, and then there's quite a few guys that are actually using them, and they say, you know what, those are great heads. They work good, especially if you do some porting and stuff on them. So it's a decent casting and can be made to make a lot of power if you do a lot of work to it. So I thought that was interesting that I found that out. They're not utter junk. They actually can be decent heads. Granted, with the smaller valves and the stock unported ports, they're nothing to write home about, but they're pretty decent. It's going to make a decent running street motor, especially for what he's doing, and plus he wants it all stock. Okay, so the plan for the heads is we're going to resurface the heads. We're going to put new valve guides in, restore the valve guides. We're going to replace 2 intake valves, and the springs, like I told you, were junk. But what I've got over here is, it turns out I had a set of comp cam springs, and gosh, I don't even remember where they came from. I think I did a big block, some big block heads, like, I don't know, probably 10 years ago, and the guy got the wrong set of springs, or we had 2 sets of springs. I think what it was is he brought me 2 sets of springs and he said, use the ones that work the best for this cam, and he ended up leaving another set of 440, 383 comp cam springs here that are brand new in the box. Now granted, I've had these for like 10 years, but I talked to the customer. I said, hey, I got a decent set of new comp cam springs for those, and I told him, I'll sell you this set, or you can buy a new set or whatever, but this is kind of a performance spring. It's got a little more tension than the stock one, so it's a little bit of an upgrade. And he's like, yeah, I'll take the springs. So that worked out really well, because we actually ended up having a new set of comp cam springs. Now, valve springs, you guys, is not an area where you want to compromise. The valve springs are critically important to proper valve and cam function, and they also really control the valve. If the springs are weak, you're going to start getting valve float, you're going to get valve bounce, you're going to have all kinds of really serious performance problems, and the springs actually determine how fast the RPMs come up when you hit the throttle. A good spring will cause that RPM gauge to spring up quicker. A poor one will cause it to be sluggish, and also how high the RPMs can go is determined by the valve spring and by having them set up right. And once we assemble the heads, I'll show you the installed height and all that stuff. So the valve springs, very critical. I don't really ever put used ones back on. I think it's foolish to do that. I don't really like the fact that we're reusing the valves, and if I hadn't mic'd these valves and discovered that they were like brand new, and then the customer told me, yeah, he talked to his dad, he said they were replaced with all new valves, I would never, if these were the original valves with all these miles on them, I would never even consider using them. I'd just tell the customer, I don't even want to do the motor if you don't want to replace the valves. But since the valves are in like pristine condition, and I know that they were replaced, we're going to go with them, except for obviously the 2 intake valves we have to replace. So that's kind of the rundown on the heads. We're going to go back now, and we're going to get to the bottom end, because I've got the bearings, obviously. So I want to get this crankshaft laid in the engine, and then once we get the crankshaft laid and this short block put together, we'll go over and we'll pop into the. We're going to have to move all this stuff over, obviously, to the cylinder head rebuilding shop, but we'll pop over there with all these parts, and I will walk you through the cylinder head rebuild process, because I'm going to do them up, do a nice valve job, guys, and all that stuff. All right, so let's get back to this short block. There's all that beautiful big block Chrysler magic. All right. So we're gonna get back to our block here. Now, I did get the bearings. I told you in the last video that I had the wrong bearings. I was actually able to get the right ones. And so now we can get this crankshaft in here. So we got our Clevite bearing set here, and we're going to go ahead and put the upper bearings in the block. And then once we get those in, there's we got to talk about the oil clearances on this engine. Now, one thing about the bearings is you never want to touch the face of the bearing with your fingerprint. I'm wearing latex gloves, the kind that doesn't have any powder or anything in them, so they work pretty good. And remember, the bearing that has the hole in it always goes into the block, and then of course the tang, the bearing locating tang, is going to line up there. It doesn't matter what order you put these in, although you do need to be aware of the fact that the center bearing is unique. The center bearing is our thrust bearing, which controls the forward and rearward movement of the crankshaft, and it has machined flanges here on both sides, and it accepts the thrust bearing. So we're just going to carefully push the thrust bearing in place, and then the rest of the bearings are all the same here on the uppers. They're all going to have a locating tang, and of course they will have the hole. The lower bearing that goes in the cap, it doesn't have an oil feed hole in it. You want to make sure you don't put these in the block. If you put that in the block, right, you're going to be in trouble. I can fit this in here. The problem with that is there's no oil hole, and now my crank gets no oil. So it's real critical that these oil holes are lined up with the oil galleries. I had a friend of mine that did a big block Chrysler one time, and this rear bearing back here, he put the lower bearing in the block with no hole and the upper bearing here, and man, was that a disaster. Needless to say, he tore up his crankshaft pretty bad. Motor had to come back apart. So we got all the bearings in, all the oil holes are lined up with the galleries, everything looks good. And then we also got to put our rear main seal in here. Our rear main seal goes back here. So this is our Fel-Pro rear main seal. Now you want to make sure that this goes in right. The larger portion of the lip is going to go toward the oil. On some of these it tells you which way they go, but on the Chrysler you're going to see the Fel-Pro part number. The part number is going to go to the outside of the block, and that lip there is going to go to the inside. So this guy, like so, just like that. There's a seal housing that goes on the back of the engine. It's an aluminum housing that houses the lower portion of this seal, and it just goes right here. Unfortunately, I don't have that piece from the customer yet. He took it off the engine for some reason, but I've got that coming. With the rear cap, this is our number 5 cap on the Chrysler. The seal housing is a separate piece, and then we have the cap. If you remember on the Ford FE, it's a skirted block like this, and the rear main is similar, but this piece here that's separate on the Chrysler is all one piece. It's part of the cap. On the Chrysler, it's a separate piece that goes in here, so we got to get that aluminum housing for the rear main seal. Okay, now that we've got the upper seal in, we want to lubricate all of these bearings. So we want to make sure that we get these bearings covered with engine oil. Okay, we don't want any dry bearings here. You don't have to put a ton of this on here at this point. We just want to keep the crank from being dry. And then of course on the thrust bearing, you want to get the sides of the thrust bearing. Make sure you got plenty of oil on that. Go ahead and lube up those bearings really good. And also, you want to make sure you get plenty of lube on that rear main seal. You don't want that thing dry, because if it's dry, the crankshaft can tear it. So we want to get a good amount of oil on the bearings and on the rear main seal. Okay guys, so at this point, one of the next things we want to do, we've got our main cap here. This is our number 1 cap, and we're going to put the lower bearing into the cap. One of the things that we need to do is we need to check our oil clearances. So we're going to put the cap on here. We've got our bolts. One tip that I would give you is when you put these bolts in, you never want to put these threads in dry. You always want to lubricate the bolts here and make sure that they don't go in dry. We've already put some lube on these bolts, so they got oil on them. So then we're going to take our cap, and you want to make sure that the cap goes in the right orientation. The cap usually has an arrow on it, and if it doesn't have an arrow on it, just remember that on the Chrysler here, the bearing notch, the locating notch on the cap, which is right there, goes to the same side as the locating notch on the block. So this cap is going to go on just like this. Now the other thing is this cap, and I've talked about this before, but this bears repeating. It's critically important. This cap is going to sit down into a pocket. It's a machined pocket here. So if you can see when I set the cap on there, you'll notice that the cap doesn't sit flush in the block. The one thing you don't want to do is start wrenching down on these bolts here and use the bolts to pull that cap up into that recess, because a lot of times the cap will get cockeyed one way or another, and you'll actually crack or break the cap here. I've seen that happen quite a few times. Fortunately, I've never done it, but that's because I was trained correctly. So what you want to do is you want to gently, you don't take a sledgehammer or anything to it, but just take a wood drift or a brass drift or something, and then you look and you visually verify and you say, gee, it's down flush on both sides. Once that's flush, now we can go ahead and torque the cap on, torque it to specs. The spec on the big block Chrysler main cap is 85 foot-pounds. And you want to torque these up evenly. Alright, once you get it torqued, always loosen your torque wrench, take the tension off of it. So now we've got our cap torqued, and I want to talk to you about this oil clearance now. Now it's important that you understand this. We want to take a look at our crankshaft here, because we got to mic the journal here. So this crank has been cut 20 thousandths undersized. We've already verified the size of the crank by miking it when we got it back from the grind shop, and it's right on where it should be. But now, here's the thing. This journal is going to go inside of that bearing housing that we just got done torquing up. So what we want to do is we're going to take our micrometer here, and we're going to get a reading on this crankshaft. I'm going to mic this journal. We're going to get right on it, and we're going to mic it. We're going to lock our mic at that size. So I set the lock and the mic is locked. Now we have to be able, so this is an outside diameter, but we have to be able to compare the outside diameter of this crank journal to the inside diameter of that crank bore with that bearing installed, because this is going to ride inside there, and there's a clearance that has to be established. The oil clearance is a gap in between the bearing that this rides in and the size of this journal. What happens as the engine is running is the oil pump is going to put pressurized oil through the crank shaft, through the galleries, through the oil galleries in the engine, and it's going to pump high pressure oil in here. And what happens as the crankshaft rotates is the oil actually separates the crank journal from the bearing and creates an oil wedge, so that the crank doesn't actually ride on the bearing when the engine's running. It rides on a layer of oil. That reduces the amount of friction that it has. It also reduces a lot of wear. So much less power is needed to rotate the crank, so that the crank is literally floating on a layer of oil as it runs, pressurized oil. That's only going to happen, that oil film is only going to happen correctly if I have my clearances right. So the amount of clearance, or the difference between the size of this journal and the size of that bore with the bearing in it is critical. On this crankshaft, we're looking about 2.5 to 3 thousandths. That's what we want to see. So now I have recorded or established the size of this. Somehow I need to take this reading and compare it to the inside diameter of that, and the way that we do that is with a bore gauge. Okay guys, so here's how this works. This is my dial bore gauge. Now I can't just put this bore gauge. This bore gauge measures the inside diameter, and you can see it's gonna take a reading and give me the measurement of that bore. But I can't just put this in there because this has to be, I'm not gonna know. I mean, I could put this in there and it says, oh, 20, you know, or whatever. What's your clearance? 20. Well, that doesn't even make sense. So what you do is you take the reading that you got on your crankshaft, right? We measured the crank. Then we're gonna take and we're gonna put our bore gauge right in between the two ends of the mic where our correct size is. And once we do that, we're going to zero out the indicator there. So if you take a look at this, I've already got this zeroed out. So I'll just go ahead and put this mic right on here, and you can see that. So I'm going to, it's kind of tricky here. I'm going to get the mic right on there. Okay, and center it up a little. Okay, my mic is right now right on those fingers. It's right in between the bore gauge ends, or in between the ends of the mic, and I've zeroed this out. So you can see 0 on my indicator now represents the size of this, okay? So now that we've calibrated this and we know what size 0 is, it's exactly the same size as this, now we can go and we can take this, we can put this in our bore, right? And we should see our difference, or we'll see our oil clearance. So let's go back over to the block and I'll show you how we do that. Okay, so now we're just going to very gently take our dial bore gauge and we're going to place it into that bore and see what our dial indicator reads. We know that 0 on the indicator represents the crankshaft size, so I'm just going to very gently put that in on that bearing. And my dial indicator is reading exactly 2.5 thousandths. So I have 0.0025. The oil clearance is actually 2 to 2.5 on this. Some books say up to 3 thousandths depending on what you're doing, but 2.5 is really good oil clearance. So now we know that this bearing bore is creating, this bearing and this cap, when it's torqued on here, is creating a bore that is 2.5 thousandths larger than the crankshaft. The resistance of the flow of oil by this clearance is what creates the oil pressure in the engine. So the pressure that the pump produces a flow, it flows into this clearance, and that clearance, that resistance that clearance creates is what creates oil pressure. In fact, one of the most common symptoms of worn out bearings down here is low oil pressure. So let's say that this bearing wears out and it gets 3.5, 4 thousandths clearance, or the crank wears, we got a lot of clearance down here, which we actually had quite a bit of wear on this crankshaft, and one of the complaints the customer had is it had, the oil pressure seemed like it was lower than it should have been, and it was. And that was because of excessive clearance here. Well, by grinding the crank to an undersize and putting the matching bearings in, we have restored that clearance. And so basically we are restoring the engine back to its former glory, and it should have really good oil pressure along with the new pump that we're putting in. So you want to do every one of these bearings. Checking oil clearance is not something you can skip. Now I did all the other ones off camera because I didn't want to bore you with setting each cap on here and checking each one. I mean, I could do that, but they're all about 2.5 thousandths clearance, which is perfect. Everything, and it makes sense since the crank was cut to a specific size, the journals are round and they're not tapered anymore, they don't have any wear, and the bearings are a specific size, that you would have the right clearance, but you have to check it. So I've checked all these, they're all good. This first one up here that we just did is the last one I had to check, and I actually checked it beforehand off camera to make sure it wasn't off. I knew it was 2.5 before you saw that it was 2.5. Okay, so our oil clearances are exactly right. Don't skip this step. My advice is you get the measuring tools. You can use plastic gauge, but I'm not a big fan of plastic gauge, although you can do that if you need to. Okay, so we've established our oil clearances are good. We've established that our crankshaft size is good by miking it, and the next step is going to be to lay the crank in the engine. So now that you got everything lubed up, you got the bearings in, you got your oil clearances checked, we are ready to lay the crankshaft in. So when you go down with the crankshaft, you want to go straight in, look at your mains, and you want to be very gentle with this thing. You just want to gently lay it in there on the mains like that. And you are good to go. Now we got to talk about putting our caps on. And again, with the caps, it's the same procedure as when the crank wasn't in there, although I'm going to add some oil here. You never want to put these bearings in dry, so we're going to be kind of generous with our oil there. Make sure that your bearing notch locating tang on the cap matches the locating tang in the block. And we're just going to go back down with our cap, get the bolts started, but again, remember, we have the issue of seating that cap. So once the bolts are started in there and we're not tightening anything down, we're just going to take our soft driver here, and we want to make sure that goes down flush all the way. We're going to repeat the same thing with all these caps. We're going to put a little bit of oil on the top of each journal, and then we are going to carefully install our main caps. Okay guys, so I've got all the caps on, got them seated, and I've actually torqued the caps to the first two steps. I recommend that you torque the caps in 3 different steps. So the torque on these caps is 85 foot-pounds, so I recommend you split that in 3. I did 35, 55, and now I'm going to 85. So this will be our final torque, and each time you do that, you want to make sure the crank turns. This crank turns real nice. You shouldn't have any binding. This crank should turn real easy by hand with no binding, no tight spots. This one feels beautiful. Okay, we're going to do our 3rd round of torque here. We're going to start in the middle, and we're going to go all the way to 85 this time. Each time you torque a cap, spin the crank. Make sure there's no binding. We'll start in the middle and we'll alternate to the front and the rear. Make sure you don't have any problems here. The crank has to freewheel. And our last cap here. And that feels really nice. Once you do that, go over them one more time to make sure you didn't miss anything. And count. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Okay, so again, take all the tension off your torque wrench. We got everything torqued up here. Another thing that I would recommend, that I always do, is I take, once I've torqued these bolts, and I put a paint mark on them. The main reason I do that is because if I have to walk away from this thing for any length of time, when I come back and take the bag off, I'll know for sure that I torqued these bolts. Certain things in life you can guess out. Building a motor, torquing mains, stuff like that is not one of them. You got to know for sure. So this crank feels really nice, and that's crank installation. Now, one of the next things we need to look at is we need to check the thrust bearing here to make sure. Now, this is the only time that I'm going to tell you it's okay to pound on this crank. We're going to take a soft hammer, a dead blow. And what you want to do is you want to take and give that crank a few whacks forward and rearward. Push the back forward. And that makes sure the thrust bearings are aligned up there. Everything's centered in there. And once you get that done, there's one other dimension that you need to check here. Once you get your crankshaft in, everything torqued, you need to check the end play. The end play is the movement of the crank this way from front to back. The thrust bearing that's in the center is what controls that. Now there's a spec for thrust bearing for end play on this crank. It should be anywhere from 3.5 to 7 on this crank. We like to see that on the loose side, closer to 5 to 7 on the Chrysler cranks. And so I'm going to get my dial indicator on here, and we're going to verify that our end play is good. Then we're just going to pry our crank back and forth, and we have about 4.5 thousandths. You can see the movement there on the crank. It's about 4.5 to 5 thousandths, somewhere in there, which is good. It's a 5/10 thousandths indicator, so yeah, that's good. That's what you're looking for. So now that the crank's installed, guys, we can start looking at these piston and rod assemblies and get these in. We're going to get the correct ring compressor for these, and we're going to start putting the rod and piston assemblies in. I'm only going to do one on camera and kind of explain it to you, because if you've done one, you've done them all. So I'll kind of show you the orientation of the rod and so forth, and how I like to put these together in such a way that makes sense.